Okay.
It's convex slope. The reason for that, and then this one in here would be a concave slope. The reason for that, and it's the best way to think about this, is that water flows downhill, which you all know, but it flows exactly perpendicular to the contour line. So this water, you can kind of see, goes this way. Where this water is always going straight down the hill. And this one's going that way. And this water gets over here, then it starts to go this way. Okay, so if this was one flow of water, you can see it starts to shift in different directions. So think of them as like little streams. This one is kind of going straight down the middle of the hill. As soon as it hits a curve that's a little bit off, it will start to turn. Where this one, from up here, you'd think it'd keep going this way, but it kind of flows and then comes back down. And if this slope does that, eventually it all flows into one spot. Okay? Does that kind of start to make sense? So when you start to think about this, the first thing that I kind of tend to do is say, okay, how's water flow? And the contour lines is what's going to help you understand which way the water flows. That'll also help you start to see how the slope works and how the grade works, and that will help with starting to see in 3D. So what you're trying to do is kind of see where is the water going and why. So when you so now with this thought process, if I have a road and the road is crowned in the middle, so the water flows, and we're going to make the water go this way down the hill. This is downhill. If this is crowned, water flows this way to the sides, right? And if it's got a curve, it runs right down the edge of the curve. But if it doesn't have a curve, if it has a ditch, it goes off the road and then down the ditch. Okay? So now I want you to start to look at how does that look from a contour side. So you can start to see contours. You can kind of start seeing by seeing the contour, you can kind of figure out what's going on in the world. So for instance, this road, if it's a dip, or if it has a curve, oops, can't draw straight today. If I want the water to go this way, the crown of the road is going to go that way, so that the water goes this way to the curb. And then the curb is up, and so it's gonna, if this is 6 inches high, the curb will go this way, and then usually out this way. So the water goes this way off of the landscape, over the curb, into the ditch, and runs down the ditch. If that same road doesn't have a curb and has a ditch, what happens is you're going to still want to have the crown of the road go this in a circular pattern, so it goes to the sides, but then it's going to go into this ditch that's down the road, and we want the water to go down the ditch, so then it goes up and back, so that this water off of the landscape goes into the ditch and it runs down the ditch. Okay, so look at those aerial photos that I provided last week. You can kind of start to see how does water flow, and that's going to just help you start to think about it. What we're going to do next is really kind of, and use these ideas of how that's going to work. What we're going to do from here on out is we're going to start figuring out grades. So when you go out, if you got the survey crew, which is a great profession, by the way, folks that, and we're going to go out. I have my survey equipment, not today, obviously. When we get to when we actually have sun for at least an hour when classes starts, which will be a couple months. What we'll do is I'll bring my survey equipment. We're going to actually go out and use it and kind of play with it, so you can kind of see how things go, so you can start seeing grades. Because it's backwards. When you're surveying, when the number gets bigger, that means the ground is going down. When the number gets smaller, it means the ground is going up. It's backwards, and it always screws people up the first bunch of times.
The big
Stadia
ruler,
rod,
and then you
yeah.
have the...
Yep. So you got a transect and a stadia rod. And I'm going to bring my 1960s or 50s maybe, because if you can see and use that, the laser levels are easy. Okay? So it's good to understand how it works. Just like you take drafting 1 before you learn AutoCAD for a reason. You need to learn how to draw before you start taking AutoCAD and start running the computers. Yeah?
Is the laser better than the eye?
No, they're both the same actually. The thing about laser is that you don't have to keep going back and looking through the eye. The laser there's a couple different kinds. There's one that spins and you can just put out the stadia rod and it shows you where it is. Or the one that you kind of aim at. Okay, so I have this is 20 feet from here to here. Okay, and it's 20 feet squared. So what happens with the survey, guys, is you got a house, you got you're gonna try to figure out what the grades are, and let's say this is the backyard. What they're gonna do is they're going to put ticks and they're going to get shots at the corner of the house. They're going to get the side of the driveway, things like that. But across the yard, that there's nothing there. You know, it's just grass. What they're going to do is they will go every 10 feet, 20 feet, 50 feet, whatever seems to be appropriate. If the ground is fairly flat, they're going to do 50 feet. If it's really kind of hilly, they might go 10 or 20 feet, and they're going to get little spot elevations. So what they're going to do is they're going to measure. They're going to get out the tape measure, go out 20 feet, make a little grid, and actually go out there and mark it, and then go 20 feet, and they'll mark the next one, and the next one, and keep going. So let's say they did that, and they bring this into you, and they give you something like 10.3, 11.4, 12.3, we'll put this one 11.7, we'll say this one is 12.3 again, let's say this one is 12.5, let's say this one's 14.1, and this one is 13.5, okay? By the way, I just made it up, it doesn't matter. But this is a good way to follow along. So now that you have these, what we want to do is we got to figure out the contour lines, those lines that we're going to fix, those elevation lines. You have the spots, but you now need to figure out how many elevation lines are in there. So this is how you do that. First thing that I do is I take my pencil and say, okay, between 14.1 and 12.5, how many round numbered contour lines you want? So you want perfect round numbers, you know. So in this case, 14 to 12, 14.1, there's probably a 14 in here, right? And there's a 13 in here, between here and here. There's a 14, 13, so 14.1, 14, 13, 12.5. And between 12.5 and 12.3, is there any whole numbers in there? Nope, so that's easy, we're done with that one. 12.3 to 11.4? 12. Between 11.4 and 10.3, is there any numbers in here? 11. Between 12.3 and 11.7? 12. 12.5 to 12.3? Nothing. Between 14.1 and 13.5?
14.
There's a 14. Now we're going to go down this line here, 13.5 to 12.3. There's a 13. 12.3 to 11.7. 12. And 11.7 to 10.3. There's 11. Okay, so generally, this helps you kind of see that there's some kind of a contour up here for 14, there's some kind of a contour for 13, there's some kind of a 12, and there's something for 11. And I put that really light because that's not accurate. It just gets you a spark. It gives you an idea so that you're not going off the reservation. Okay? So now here's the math. Math is equal to slope is equal to rise over run. This is algebra, back to algebra. If you have any two of those things, you can do the math. You have to have two. It means you can figure out just about anything with two of those three items. If you know the slope and you know the run, you can figure out the rise. So what that means is the slope is the percent of grade going down the hill. The rise is right here, that acts how high things go, and the run is how far it goes. Okay? So doing this quick, I don't want to spend too much time on math, but we're going to be doing this. This is the equation you're going to be doing the rest of the semester, so please pick it up. Is if you know the distance is between 2 points is, in our case, 20 feet, and we know the rise for some of them, let's say 12.5 to 12.3 is 0.2, right? What's the slope for that area? So if you do 0.2 divided, the slope is equal to 0.2 divided by 20, which is equal to 0.01, or times that by 100, and it's equal to 1%. It's a 1% slope. Does that all make sense?
Which one did you do?
I didn't do
Yeah.
any of them yet. I
Oh, you
just
haven't
let
done
it run
anything?
up. I'm just showing you what that is. So if you do slope is equal to, and you know rise over run, this is the easiest equation.
Okay.
Okay? Okay, let's say you don't know, you know the slope. Let's say you know the slope is 10%.